Today we're going to be looking at mathematics, trigonometry, grade 12 syllabus. Okay. The foreword is and the table of contents not so important, right? So there are certain study and examination tips you need to learn in this trigonometry section. So all learners should. Okay, that's fine. All right, that's fine, that's fine, that's fine. All learners should be able to acquire sufficient understanding and knowledge to develop fluency in computation skills without relying on the use of a calculator. These learners need to be able to generalize, make conjectures, and try to justify or prove them. They need to be able to develop problem solving and cognitive skills. They need to be able to make use of the language of mathematics, identify, investigate, and solve problems creatively and critically. They need to be able to use the properties of shapes and objects to identify, investigate, and solve problems creatively and critically. They need to be able to encourage appropriate communication by using descriptions and words, graphs, symbols, tables, and diagrams. Learners need to be able to practice mathematics every single day. So this is just one of those key things here. Learners need to be able to practice mathematics every day, daily. Right, as an overview of the mathematics, we shall obviously be following these highlights, or we shall be looking at the trigonometric ratios, which involve the three trigonometric ratios: the trigonometric sine, the cosine, and the tangent. We shall be looking at two-dimensional and three-dimensional problems, the 2D and 3D problems. We shall be looking at trigonometric graphs. We shall focus on compound angles. We shall look at these compound angle formulae. Okay, these four compound angle formulae. We shall be focusing on the negative angles. We shall be looking at identities. We shall be looking at the sine rule, the cosine rule, the area rule. We shall be looking at these identities, the trigonometric identities, the fact that the sine squared plus cosine squared is 1, and the three identities for cosine 2x, where the first one is cosine 2x is cosine squared x minus sine squared x. Okay, but cosine 2x is also 2 cosine squared x minus 1. All right, so but cosine 2x is also 1 minus 2 sine squared x. Okay, there's another one that says sine 2x is 2 sine x cosine x. Okay, so that is one more. So you need to learn this, and we shall learn them today. Okay, so these pertains one just overview of the trigonometry topic we shall be focusing on. Okay, right. Now, we're starting with examples. So we shall look at an example that focuses on what we call the trigonometric ratios. Use the sketch below, okay? Write down the trigonometric ratios of angle B and angle C, okay? We learned at the top the trigonometric ratio. So this is the sketch given to us. So if we are to find, for instance, the trigonometric sine of B, the cosine of B, okay, so we also have the cosine of B, but we also have the tangent of B. Okay, so what is the sine of B? Okay, this is B. Right, so we remember the SOHCAHTOA, right? Remember the SOHCAHTOA, so that the sine is the opposite over the hypotenuse. Okay, so you possibly obviously will be going on and off sometimes if there's some interference, network interference, but once again, this lesson is fully recorded, so you'll be able to watch it immediately afterwards. I'm going to make it available. I'm going to send the link to the video. Okay, right. So if you have the sine of B, for example, the sine of B is the same as what? Okay, so these work in a right-angled triangle. So ideally, you need to tell the examiner, that means the examiner, you're working in a specific triangle. So the B is in the triangle ABD. Okay, so which is a right-angle triangle. So we have the sine, which is, yes, please. All right, thank you. Okay, just 1 second. Okay, thank you. All right, thanks. Right, so we continue with our lesson today. Continue with our lesson today. So, now, we have the sine of B. So we're working in the right angled triangle. So these trigonometric ratios always work in a right angled triangle. Okay. So if you were dealing with the sine of B, for example, what is the sine of B? So the sine of B is going to be opposite of hypotenuse, in which case we're focusing obviously on that triangle there. Then the opposite is going to be exactly AD, okay? That is the opposite, or whatever, opposite over the hypotenuse, which is AB. Okay, which is exactly what the examiner wrote. And then also we'll have to find the cosine of B. Right, so the cosine of B is going to be adjacent of hypotenuse. So if you have the cosine of B, which is adjacent, which is BD, over the hypotenuse, which is AB. And then the tan of B is going to be opposite over hypotenuse. So if this is the angle B, the opposite is actually this side here, which is actually AD over the adjacent side. Okay, so what is the adjacent side? So the adjacent side is actually this one here, which is BD. Okay, so what have we done right now? We have found the trigonometric ratios of the angle B, okay, which is what the question wanted, because the question said, write down the trigonometric ratios of angle B and angle C, right? So now we also need those of the angle C, right? So the angle C is actually this angle there. So we're dealing now with this one here and this in that. So we're actually dealing with the blue triangle, right? So dealing with the blue triangle, we tell the examiner, that means the examiner, we're in triangle ABC. All right, so which means therefore, if you have the sine of C, which is opposite of hypotenuse, so the sine of C, which is opposite, which is exactly AD over the hypotenuse, which is AC, but we also have the cosine of the angle C, and the cosine of the angle C, according to the trigonometric ratios definition, the cosine is adjacent of hypotenuse, and therefore the cosine of C, this is the angle C, is going to be the adjacent, which is actually the side DC over the hypotenuse, which is the longest side, the hypotenuse, in this case being AC, opposite the 90-degree angle there. Okay, moreover, we also have, if we're just to find the trigonometric ratios of the angle C, okay, the tangent of C. All right, so this is opposite of adjacent. So the tangent of C is going to be opposite, which is AD, right, over the adjacent, which is DC. All right, so that is what we get, and precisely is actually the result there. It is the result there. Okay, so we found therefore the trigonometric ratios of the angle C. Okay, so because that's what the question said, write down the trigonometric ratios of angle B and angle C. Okay, and you need to solve for BD and AB, right? So we need to solve for BD and AB, right? So in this case, if I'm to clean this up a little bit to make sure that this is quite tidy. Right, so if we are to solve for BD and also AB, right, so here is B and here is D, we need to solve for this side here. And also we need to solve for AB, okay, here is A and here is A and here is B, we need to solve for this side. Okay, so how do we solve for these sides here? Okay, so again, solving for these sides is very, very easy. And this is how we shall do it. Okay, so now to solve for these particular sides, one way to do that, for instance, can be to say, where do we have a length? The length that is given is only the 15. If it's only the 15, then we need to actually use the 15 to find these sides I've indicated with the question mark or with question marks. So how do we do this? We're going to use any of the trigonometric ratios. So one way is to get, for instance, this side here. If you get this side AD, then we can actually be in a position to use that here constructively to get that. So we can say, for instance, in number 2, we can say in triangle, can choose to work in triangle ADC. Okay, in triangle ADC, we're going to have, for instance, the trigonometric ratios. Okay, so if we want to find AD, find AD, and we have the hypotenuse, so we can obviously writing SOHCAHTOA. Writing SOHCAHTOA. So we're going to say this sign. So the sine of 70 degrees is the opposite, which is AD over the hypotenuse, which is 15. In which case, therefore, it is AD equals 15, the sine of 70. Right, we're going to use the calculator to do this one, but it has already been done for us. So 15 times sine of 70 is actually 14 with the decimal comma 0.95. All right, so this is what we're getting. You know, it is actually units. Okay, it doesn't really matter what the units are. In fact, particularly in this case, it is in meters. So we just write the meter. Okay, we simply write down the meter. So it is actually that meters. Okay. Now, with that being said, we've already found the length of AD, for instance, or that means we have this one. So this is actually 14.095 meters. Okay, so if it is exactly this one here, okay, we have already got AD. After having got AD, we can then be able to find that one, because we can say, okay, now we have the opposite side. So this side is opposite. So this is the opposite side. And then we also are dealing with the hypotenuse, for example. This is the opposite side. We also are dealing with the adjacent side. So we can use those trigonometric ratios. So we're going to find, for instance, first the length of AD there. So we're going to say, for instance, at this point, we can write that here. We can say, or I can write it, it's okay here. Right, so I can say in triangle ABD, right? So we have what? Okay, we have the opposite side. We're interested in the hypotenuse, and therefore we use the sine. Opposite and the hypotenuse is the sine, so which means the sine of 47 degrees is the opposite, which is 14,095 meters divided by the hypotenuse AB. So which means we can be able to find our AB So which means AB is 14,095. 14,095 divided by the sine of 47 degrees, which means AB is given by the following. Right, so you divide these things here. Now, if you look very carefully, that is going to give us AB, for instance. Okay, so and now we can get AB that way. Okay, so what does it give us? Okay, right, what does that give us? All right, so it is exactly what was done here, because they considered the sine of 47 degrees, which is AD over AB, which is what I actually have worked on here. Okay, so it's exactly what the examiner got to. Okay, so after they did that, then they just decided to put the whole thing. So it's just the same thing. Okay, so we do AB. Right, so with this being said, so the steps are actually the same. So AB is going to be this. So AB is going to be 19.27 meters. That is the length of the side AB, okay? Now, the next thing we're going to do is to continue and find another side. Right, so what other side is there? We also need this side BD. So now, to find this, the length of BD, we proceed as follows. We proceed as follows. You can just clean this up. Okay, I can clean this up. So we proceed as follows, and we focus on BD. So we're going to say also we are dealing with the triangle. So we are actually operating in triangle BAD, in the bad triangle. In the bad triangle is bad. So now we're going to say, all right, so we're dealing with the opposite and then the adjacent, right? Opposite and then the adjacent, so that is the tangent, all right? Never mind that. So, okay, I'm looking at this material because it's really very important for exam purposes. Right, so the opposite is going to be 47 degrees. Opposite 47 is going to be exactly AD over the adjacent side, which is exactly BD. So with this said, we cross multiply this way, and the BD will actually come to the position of the tangent AD here, and this is the tangent of 47 degrees. So which means that BD is the same as AD, right? AD we already know, it's that one. Right, so it is exactly 14,095 meters. We divide it by the tangent of 47 degrees. And what is our BD side? Okay, so that is what we get there. Right, that is what we get there. Okay, so if you do that very, very carefully, it will become something very, very interesting. So, I said already, another way to do that would be to use the cosine, for example. So you can also use the cosine of 47 degrees. Right, if you use the cosine of 47 degrees, okay, so you're dealing with the triangle, this one. This is 47 degrees. And then that is A, that is D. So the cosine of 47 degrees in this triangle is going to be what? Okay, in view of tower. So which means the cosine here is adjacent over hypotenuse. It is adjacent over hypotenuse, so it will be BD over the hypotenuse, which is AB, right? Which is exactly the same idea as the above. So the results will be the same. Okay, would have found, for instance, so if you cross multiply these, it will be BD, you could multiply like this, or it's going to be AB, the cosine of 47 degrees, which is BD. So the answer becomes something, something, something. Okay, they've got it here. Right, so because AB would have got that and divide, so that will be the same here as the BD is going to be 13 comma that. But first, I'd be interested in just demonstrating something. Demonstrating that AB would have been determined, so which would be 19,27 or a decimal point. We have 47 degrees. Normally, some countries like the British use the decimal point, and we use the decimal comma in South Africa. So you have, for instance, BD, which is 19,27 times cosine of 47 degrees, which is actually 13,14 meters. That gives us actually the length of BD. But now I want to mention something here about the following. Okay, so just note a couple of things here. So we shall have, for instance, 14.095 divided by the tangent. Okay, this one here is what I'm just experimenting on my calculator. The 14.095, you divide it by the tangent. Okay, so you divide it by the tangent of the denominator, the tangent of 47 degrees. Right, and therefore the result becomes exactly 13,14 meters. So it's exactly the same as this and that. So we are in business and all is very well. So we have answered the question. The question was solve for BD and AB. We have solved for BD because the length of BD, we found it to be 3,14, but we also solved for AB. Okay. Also solved for AB, and we got 19,27. Okay. Once again, this you'll have a chance to watch, but this is very easy. Okay. I would want to just recap on prior knowledge so that you just remember these things, and each time you watch the video, you're able to just remember. In view of the idea of what we call which is a frequently used mnemonic method to remember, the trigonometric sine of theta is always the opposite of the hypotenuse. The trigonometric cosine of theta is always the adjacent of the hypotenuse. So you know that, adjacent of hypotenuse. The trigonometric tan of theta is always opposite of adjacent. All right, so you have the Pythagoras theorem then, which is PR squared plus QR squared, which is PQ squared. So this is what we call the Pythagoras theorem there. Okay, so the Pythagoras theorem works in a right-angled triangle. Okay, nothing very much obvious. You remember the following identities. I want to just mention them in passing. They're very basic. That the trigonometric sine squared of A plus cosine squared of A is equal to 1. The tangent of theta is the sine over the cosine of theta. Right, so you also have that the tangent of theta is the sine over the cosine. This is called the quotient. The quotient identity. It's called the quotient identity. All right. And we can prove this. Okay. In fact, it's being just established there. We'll prove this. When dealing with fractions, we find the LCD and so on. Okay, so there's just a note here that if we know that the tangent of theta is actually the sine of theta divided by the geometric cosine of theta, we can say 1 over the tan of theta is actually the cosine of theta divided by the sine of theta, in which case that is the result we have. So 1 over the tangent of theta is cosine theta over the trigonometric sine of theta. Okay, so the students must be able to prove these identities for examination purposes. So it's very important that one is able to prove these identities there. Okay. Now, how do we prove that the trigonometric sine squared of a plus cosine squared a equals 1? Let's look at the proof together. Okay, the proof has been done alongside, but we shall just recap on the proof together. Now, to prove this, first and foremost, we need a diagram. First things first, we need a diagram, and the diagram has been drawn. Right, we're going to just draw a basic diagram. And we draw our diagram this way. We put in the first quadrant. This one is the first quadrant. This one is the second quadrant. This one becomes the third. And this becomes the fourth quadrant. This is the first quadrant. And if that is the case, we're able to make the following observations. That we want to prove something there. So we're going to work in a, so if we want to prove the sine squared of a plus cosine squared of a is 1, so we're going to have these and we put the triangle, the angle A in standard position. So the angle A is placed at the origin, always. After you place the angle A at the origin, pretty much the rest of the other angles, you can put them anyhow. So that here it's B, here is A, and here it's C. We continue. And this obviously is our usual x-axis, and that is our usual y-axis, so that we're able to find the trigonometric sine of A. What is the sine of A? Right, so the sine of A is going to be actually, if the angle A is measured always in a counterclockwise direction from the positive x-axis, you'll say the sine of A becomes the opposite over the hypotenuse. Right. And also, you'd need the cosine as well. So you'd say the cosine of theta, the cosine of the angle A at the origin there. Okay. So the cosine is the, according to SOHCAHTOA, the adjacent over the hypotenuse. So it's going to be actually that. And therefore, we are in business and we continue to solve this problem. Right, so if we continue to solve this problem, we shall solve the problem as follows. So we then say we take a side, and now a side of this identity, you can call it the left. Okay, the examiner left that part, but you can say, okay, let, Mr. Examiner, the left-hand side. So if you're proving, you must have a left and a right. Normally, you must have two sides of the equation. Right, so you therefore have the left-hand side, which is the trigonometric sine squared of A plus the cosine squared of A. What is the sine of A? So it is A over C, you square that. The cosine squared becomes B over C and you square it. So this is A squared over C squared. This is B squared over C squared. You take the LCD C squared. If the LCD is exactly C squared, what next do we achieve? So this becomes A squared plus B squared. Right, so if you have these, what is A squared plus B squared? All right, so if you look at these here, A squared plus B squared, it's Pythagoras theorem. So A squared plus B squared is C squared, and this is called Pythagoras theorem. Pythagoras theorem. Right, so if it is Pythagoras theorem, it means, therefore, if you have the following, A squared, so it is C squared over C squared, which is 1. And therefore it is the right hand side. So which means we have the sine squared plus the cosine squared which is 1. We've proven this, very basic. It's a very examinable concept, but because it's too basic, it has not really gained much attention. But I must indicate that this book is from the Department of Education, and the truth is, it is everything the exam will ever contain in this curriculum. So it's very important that you learn the contents of this book. Okay, right. So we need to be able to prove. So once again, there's just a note that we have proven that sine squared A plus what? Plus cosine squared A is 1. But we can transpose terms, like we can say sine squared is 1 minus cosine squared. Or alternatively, we can start by writing cosine squared. If you write by cosine squared and you transpose the sign, it becomes 1 minus sine squared. These two equations are equivalent. We want to prove this. We want to prove that this is true, and this is that is obviously an identity that involves squares. Okay, so you can call it that way. Okay, now something called the quotient identity. How do you prove the quotient identity? How do you prove the quotient identity? To prove the quotient identity is very easy. First things first, every time you prove these identities, you must draw a diagram. Ideally, you draw a diagram and you put your triangle in the first quadrant, preferably, but otherwise the triangle can be put anywhere. Right, so obviously, if you are to prove that RTP required to prove. So you are required to prove that, for example, that if we have the tangent of theta, it is always the sine over the what? Over the cosine. So with that said, we're able to see as a consequence that we shall be able to prove this very, very successfully. All right. All right. Shall be able to prove this very, very successfully there. All right. So we continue along those lines. All right. So we shall continue along those lines, and we are in business now. All right. So all right. So we continue. How do you prove this? You take a side and you prove that it is equal to, the examiner decided, the person who wrote this book decided to take the right-hand side of this, so we can just take the right-hand side. It's easier that way. So now we then say you let the right. In this case, the right-hand side is the what? Is the sine over the cosine. So this angle here, if you prove the identity, so the angle must always be actually at the origin. All right, so we continue. We continue with these here, and we shall solve these together. Okay. So which means now we shall have the sign from this. Right, so we have A here. We can put the B, the C there. The B and the C can be put pretty much anyhow. So that opposite angle A is lowercase a, opposite angle B is lowercase b, opposite angle C is lowercase. So you have those small letters there. And therefore, now if you have the sign of theta, you use the frequently used mnemonic, okay? So it's SOHCAHTOA. So using SOHCAHTOA, you have the sign of theta, which becomes the opposite over the hypotenuse. So opposite, the theta is A, the hypotenuse is C. Okay, so you note that one? And we have the cosine of theta, which is actually the adjacent over the hypotenuse. So the adjacent over the hypotenuse. So we have that. Okay, so we continue. Right. We continue now. So if we have this, then this A over C, we divide it by B over C, is A over C multiplied by the reciprocal of C over B. So in these is the same as A over B. Now, if this is the diagram, or my diagram, A over B is opposite over adjacent, and it is the tangent of theta. So, which means the conclusion is that we have therefore proven that this is equal to the left-hand side. We started with the right, and this equals to the left-hand side. So therefore, you have the sine of theta over the cosine of theta, which is the tangent of theta. All right, so, and these becomes the answer, becomes the solution. Okay, now there are a couple of things, therefore, so we have proven that sine of theta over cosine theta is the tangent of theta. Or obviously it can be the other way around. It can be written the other way around. You can write it as, for instance, the way it has been written there. You start with the tangent of theta, and you write the tangent as the sine over the cosine. All right. Now let's get another example that's very, very interesting. Here's an example. How do you prove this? So here they're saying, prove the following identity, that this is 1. Right, so we can be able to prove that. Yes, please. All right. Okay, just 1 second. Okay. All right. Okay, so we continue. We continue with our discussion here. And now we want to prove something. Right. I can just remove this. Okay. This you'll have a chance to watch. But I want to prove the identity in the green block. How do you prove the identity in the green block? So you let the left-hand side, this one, be 1 minus the trigonometric sine of beta into 1 plus the trigonometric sine of beta divided by the cosine squared of beta. So, which means the left-hand side becomes the same as. Okay, so to expand this now, you use the FOIL method. These are the first. Right, so these ones are the outers. These guys here are the inners, and these are the lasts. So we call it FOIL, where the F stands for the first, and the O stands for outers, the I stands for inners, and the L stands for the last. Okay, so just a note on the FOIL method there. All right, so you continue. So the left-hand side. So 1 by 1, if you look at the first, it's going to be 1. The outers, 1 by the sign of beta is going to be the sign of beta. Minus sign beta by 1 is minus sign beta. Minus sign beta times sign beta is minus sign squared beta. So 1 minus sin squared beta. What is 1 minus sin squared beta? Is cosine squared beta. And therefore, cosine squared plus cosine squared is what? Is 1. So the left is equal to the right. Right, so hence, this equals that because cosine squared beta is 1 minus sine squared beta. Yes, I'm happy that, yeah, I'm yet to engage you, in fact. I'm yet to give you assessments, okay? So I'm trying to build some foundation so that you can have a very balanced understanding of trigonometry. Right, so the conclusion, therefore, is thus, it is thus 1 minus the trigonometric sine of beta into 1 plus the trigonometric sine of beta divided by the trigonometric cosine square of beta. This result is indeed 1. It has been proven. Okay, right. So this was just one example here because the examiner said in example 2, prove the following identity. That okay, this is what the examiners use in South Africa. Just each time when the exam is to be set for matric, the rules are they need to set the exam within the ambit of this guide. Okay, so this guide is extremely important. Here's another example. Prove the following identity, that this is equal to the trigonometric 10 squared. So it's the same thing. So to prove this, you'll have to take a side. So you're going to let a side be. Take the most complicated, that is the hint. So you're going to let the left-hand side be the trigonometric sine of alpha, the trigonometric sine of alpha, cosine alpha. Cosine alpha, 1 minus sine squared alpha. And this is the left-hand side. So at this point, you're going to factor this out and have the trigonometric sine of alpha, which is 1 minus cosine alpha. So if you take out the common factor, the sine of alpha, you cross it out, and then you're left with a 1 in the place, with 1s in the place of the crossed out common factor. Next, we deal with the denominator. It doesn't obviously look as if there is a clear common factor, but we know that that one is that. So we know that sine squared alpha plus cosine squared alpha is always 1. We transpose this one, which means cosine squared alpha is 1 minus sine squared alpha, which is the same as cosine that minus cosine squared alpha. This is the left-hand side, which is the sine of alpha into 1 minus that. all divided by, so you have cosine alpha into, so if you have the cosine alpha at this point, what you do is you cross out, you can take common factor, you cross out, you're left with 1 there. Here you cross out, you're left with 1 because there were 2 of them because of the square. Right, so cosine alpha taken out as a common factor, you're left with 1 minus cosine alpha. Right, so at this point, you have this as a common factor. You therefore have the left-hand side, which becomes the sine of alpha divided by the cosine alpha ions. Now, what is this? This is tan alpha, which is the right-hand side. And there was an error in this question, okay, because there's no square there. Yeah, the square was accidentally put in the typing of this material, but surely the square is not there. Okay, surely the square is not there. Right, so we continue with this. So we've proven that, and they go to that. There's some activities. So these activities, please, you need to do them. Okay, you are seeing them now, and then you're gonna do them because I'm expecting you to know them. These activities, I'm expecting you to know them. Right, so make sure that you learn them. You try them, and the answers are already there. Right, so I'm going to demonstrate these because they're very easy. So if I do these activities, you need to try them also. Okay, for example, I'm just going to do this very quickly. Like this one here, you need to simplify. Right, the geometric tan, we've already seen it is the sine over the cosine times the cosine, and this cancels out. It gives us the sine, and we're done with the simplification. Okay, there's no further simplification. The result is a single trigonometric ratio or an integer. When you simplify, you must get one of the two things. Either you get an integer is the result, or you get a single trig ratio. In which case, we got a single trig ratio. Okay, so we multiply here. We multiply 1 by 1, you get 1. You multiply 1 by the cosine, which is minus cosine theta. You multiply this by that, which is plus cosine theta. You multiply this by that, which is minus cosine squared theta. You divide everything by
Sine.
the sine of theta. So I'm happy that you're wide awake and you are very participative, which is wonderful. So in the case of this, then these two cancel out. And then you have 1 minus cosine squared of theta divided by the sine of theta. But 1 minus cosine squared is what? Is exactly the sine squared. Sine squared of theta divided by the sine of theta. And therefore, this is what? If you divide them, you get the sine of theta. Okay, because if you divide the sine squared, you remove one factor. Because the sine squared is the same as the sine of theta times the sine of theta, and is divided by what? By the sine of theta. And therefore, this is that. So you get the sine of theta. Right. So I want to prove, I want to like verify. This is what these activities, you'll do them as well on your own. Okay. But I'm just doing them sort of just you can just have some common understanding here. Right. Here you take something called the lowest common what? Denominator. The lowest common denominator. So it is exactly cosine squared theta. Right. So you have cosine squared divided by cosine squared. 1 by 1 is 1 minus. Cosine squared divided by 1 is cosine squared by that, which is cosine squared. What is 1 minus cosine squared? It is sine squared. Divided by cosine squared. What is sine squared over cosine squared? It is tan squared. Well done. So it is exactly the tan squared of theta. Okay, so that will be the result there. And some of these have already been done because like the first one, we've proven it is sine theta and we've proven it's sine theta. The second one, we've proven that it is also sine theta, but the first one was sine x, and we got sine theta. This one we've proven that it is actually the tan squared, and they've established the 10 squared there. Okay, so we just have this one as well. This one, number 2, is very straightforward. I'm just going to do it now here. Okay, so you can do it anywhere. Right, so if you have 1 plus, you can take one side here and prove it. So it's easier to take the left. So in number 2, so in number 2, you're going to take let the left, which is what? Divided by 1 plus sine theta, which is 1 minus sine theta. You divide, which is 1 plus sine theta. 1 minus sine theta. You divide this by sine 1 plus sine, you get 1 minus sine. This one divide by 1 minus sine, you get 1 plus sine. So the minus sign in that cancel out, giving us 2 divided by. So in the denominator, you multiply 1 by 1, you get 1. 1 by minus sine, you get minus sine theta. The sine by 1, you get plus sine theta. And the sine by minus sine, you get minus sine squared theta. This is 2 divided by. So we cross this out, which is 1 minus sine squared theta. What is 1 minus sine squared theta? It's cosine squared theta. Okay, so now this is pretty much the right hand side because that's what they sort of wrote. They said obviously this is equal to 2 over cosine squared, and we have simplified this and got to 2 over cosine squared, which is actually the right hand side. So the identity has been proven. Okay, now the proof is done. Okay, this is recorded, our discussion is recorded. Okay, here's a very simple one, 1.3, or in number 3, we need to just complete. Right, so you need to complete this is equal to this. So this is straightforward. You need to just remember that a squared minus b squared. What is a squared minus b squared? It is a minus b into a plus what? A plus b. Okay, what do you call this identity here? Have you ever seen it before?
No.
A squared minus b squared is equal to a minus b into a plus b. What's the name of this one? It's done in grade 10. And then there is a cubed minus b cubed is a minus b into a squared plus ab plus b squared. What do you call this other one? This one? Okay, never mind. I'm just teasing you. Okay, I'm just pulling your leg in the process. Just kidding. Okay. But this one is called the difference because of the minus. It's called the difference of 2 squares. This one is called also a difference. This one is called a difference. It's called the difference of 2 cubes. This one, difference of 2 cubes. There's also a sum of 2 cubes.
These
You see them, yeah, you see them sometimes when you do the factor theorem and then you're factorizing and then you're doing long division, things like that sometimes. Okay. Yeah, in those areas. So I'm mentioning that because they're saying you need to complete in number 3. So in number 3 now, this is 1 squared minus sine squared theta. So it's like that. So you have that squared minus that squared. So you put the 1 minus, like in a squared minus b squared, you put the a minus b into a plus b. So you put the 1 minus sine, and then you're going to put the 1 plus sine theta. Okay, because it's always minus and the plus as long as it is that squared minus that squared. This is called the difference of two squares because the squares are 2 is a squared minus b squared, only 2 squares there. Okay, and hence prove the identity. Okay, now you need to use that to prove this identity. Right, to prove this identity, it's easier to always start from the complicated side. So you're going to start from the left. Okay, let's just practice with that one. Right, so obviously they've done it there, but we're going to just do a practice of number 3. Right, so we're gonna take the left-hand side. So the left-hand side is what? Is 1 minus sine squared. It is actually 1 minus sine squared A divided by cosine A into 1 over cosine A plus 10A. Which is cosine A into 1 over cosine A plus 10A. 1 over cosine A plus 10A. So which means the left-hand side is, what is 1 minus sine squared? It is actually cosine squared. Okay, so which is cosine A. And then now you continue. Right, so this is over 1. So that you have cosine A. And then cosine A over cosine A is 1 by 1, which is 1 plus cosine A by 1, which is cosine A times the 10 of A. So it is cosine A times the 10 of A. Right, so it is cosine A times the 10 of A. So which means the left-hand side is, okay, now we can just simplify this one. Right, so to simplify this at this point, you just say the following. You just say the cosine will divide 1 from this, the 2 factors of the cosine, leaving us with just cosine A. You divide that by, so you have 1 plus cosine A, sine A over cosine A, all divided by cosine A. The left-hand side. These 2 things cancel out, giving us cosine A divided by 1 plus sine A over cosine A. Right, so what is this? Here we can continue and obviously be able to establish something pretty interesting. Right, so at this point you have the left hand side, which is cosine A. We can write like that, and then have the following. Okay, so you can write cosine A and then you divide by 1 plus sine A over cosine A. So the left becomes cosine A, you multiply by cosine A over 1 plus sine A. I'm trying to teach today, sort of, okay. Trying to just do the basics a little bit. So cosine A by cosine A is cosine squared A, which is divided by 1 plus the trigonometric sine of A. This is the left-hand side, which equals, what is cosine squared? It's 1 minus sine squared. Okay, so we use that result that they said we had to complete. So we have a difference of 2 squares. If you have a squared minus b squared, it is always a minus b into a plus b. So this one is 1 minus sine a into 1 plus sine a divided by 1 plus sine a. So as a consequence, these 2 things cancel out. And we have the left-hand side, which is 1 minus the sine of A, which is the right-hand side. Imagine this the right-hand side. Because to simplify your proof, just check. It is 1 minus, the right-hand side is 1 minus sine A. And we've been able to achieve 1 minus sine A, which is the right-hand side. Okay. So we have those. Okay, we have proven those. Right, so these exercises, they're pretty much the things we went through. So you can just practice with those. Okay, and obviously I want us to spend some time on things we call the reduction formulae. The reduction formulae are extremely important for us to learn. They are very much examinable, so you need to expect them to feature in the exam, and so you need to learn them and make sure you don't just learn them, but also you understand them, these reduction formulae, because if you understand them, then you'll be in a position to succeed. Okay, you'll be in a position to succeed. All right, so that is what you need to do there. So we are in business. We are in business. Right, so we're going to look at the student must be able to derive and use reduction formula to simplify the following expressions. Right, so we shall be dealing with the sine and the cosine, the sine, cosine, tangent, etc. Shall be dealing with this, and shall be dealing with things we call the negative angles as well. Prior knowledge, obviously, that you need to have is on trigonometric ratios. You've already done. To derive and use trigonometric ratios, we've derived the trigonometric ratios. There are some identities that are involved. Problems in the Cartesian plane. We have learned how to sketch in the Cartesian plane, how to position our triangle, etc., in the Cartesian plane. Right. Definition of concepts in theory or theory. We have the reduction formulae. Okay, and now our friend here we call the cast diagram: quadrant 1, quadrant 2, quadrant 3, quadrant 4. And obviously the position of these things. Okay, here is the cast diagram, and it's a very important one for us to learn. Okay, obviously we start and say this is 0 degrees, 90 degrees, 180 degrees, 270, and 360 degrees. So if you are here and we go back like this, it becomes 180 degrees minus, but if you go like this, it becomes 180 degrees plus. Okay, if then now this one is 360 degrees, but if we decide to go back, it's 360 minus. In fact, if we decide to go beyond, it's going to be 360 degrees plus. Okay, right. Moreover, there are some additions that we can pretty much learn from this situation. Okay. In quadrant 2, for example, in this quadrant 2, so we have 180 degrees minus, so we can take the sine, cosine, the tangent of each of those there. Okay. So like the sine of 180 degrees minus theta. So obviously we know that according to the cast rule, it's only the sine that is positive. So if you have the sine of 180 degrees minus, it's going to be positive sine theta. Then you have the cosine of 180 degrees minus, which is there, it's going to be negative because the cosine is negative there. Then the tangent of 180 degrees minus is also negative. In other words, the cosine and the tangent are negative, but the sine is positive in quadrant 2. Okay, if you look into the quadrant 1, the reduction formulae are not used on angles less than 90 degrees. Okay, on angles less than 90 degrees, there's just the statement that the reduction formulae are not used. Well, the understanding is that on angles less than 180 degrees, obviously all the trigonometric ratios are what? Are positive. So it becomes very pointless to even begin to deal with those angles that are less than 90 degrees, which are in the first quadrant. Everything obviously becomes positive. But we shall have a discussion on that. In quadrant 3, we have 180 degrees plus, so you can put the sine, the cosine, the tan, but it's only the tan that is positive. The rest are negative. In quadrant 4, it's this one. So this is 360 degrees, but if you go back, you subtract. And if you go further more, there you add. So going back, I mean, from 360, you're going back to 270 because you're moving 0, 90 plus 90 is 180, plus 90 is 270, plus 90 is 360. But when you get to 360, you go back, so it becomes 360 minus. So 360 minus positions us in the fourth quadrant where we have the cosine. So we have the sine, cosine, and the tangent. But we know very well that the cosine is the only trigonometric function that is positive. So in other words, cosine is positive and the sine is negative and the tangent is also negative. There are certain things you call negative angles, and these negative angles remain very, very important. Like if you, yes, please. Okay. Right. Just 1 second. All right. Okay. Thank you. Right. So we continue. Let's continue with our discussion right now. All right, so we continue, and we need to solve the following. Right, dealing with the negative angles, there are a couple of things we need to do. Negative angles, what are the negative angles? So the negative angles, for instance, in quadrant 2, that will be the negative angle, 180 degrees minus theta. I'm just going to draw a rough Cartesian plane here, like this. And you're going to have that. So you're going to have, for example, that if the angles are negative, the negative angles, so they're measured clockwise, in the clockwise direction. So that is 0 degrees, minus 90 degrees, minus 180, minus 270, and minus 360 degrees. Moreover, if that is the case, so you can decide to add. So if you want to say minus 180 degrees minus theta, you'll actually be going further. But if you say minus 180 degrees and then you add theta, you'll be going back like this. Now, this is our usual cast diagram, so nothing strange. Now, at this point, if you are at, and you have, for instance, at minus 360 degrees, right, you go a little bit back there. But if you are at minus 360 and you have minus 360 degrees minus, so you'll be going further. Okay. But also when you are going like this, you're starting here, you can consider a minus, like a minus theta. Okay, it's a very important type of angle, this, because it comes here. So in the fourth quadrant, we have minus theta. We say that. Where theta is, you can take it to be what you call an acute angle. An acute angle is that kind of angle less than 90 degrees. All right. So if you have the sign of minus theta, for instance, so you think of it as being in the fourth quadrant, and the fourth quadrant, only the cosine is positive. All right, so only the cosine is positive, the sine is negative, and the tan is negative. So if you focus on quadrant 3, if you focus on quadrant 3, right, so quadrant 3 is obviously this one here, you'd be having this one, because the minus 180 plus. Why is it minus 180 plus? Because this is minus 180. But if you add theta, maybe you can think of theta like as an acute angle like 30 degrees, plus 30 degrees. So minus 180 plus 30 would be minus 150. So if we're moving from minus 90 to minus 180, minus 150 degrees is somewhere in the middle here, between minus 90 and minus 180. And minus 150 is a negative angle because it's minus 150. Now, in the third quadrant, the tan is the one that is positive, but the only one. So you realize, therefore, that the tan becomes positive, but the cosine is negative and the sine is negative. In quadrant 2, you'd have minus 180 minus that. So in quadrant 2, it's only the sine that is positive. So you realize the sine is positive, but the cosine is negative and the tangent is negative. And now adding or subtracting 360 degrees does not change the value of a trigonometric function. For example, if you have the sine of theta and you add 360 or you subtract 360, the sign does not change. Cosine of theta, you add 360, subtract 360, it's still plus cosine. Theta plus, or you're subtracting 360, the tan remains plus. Functions allow us to write a ratio of sine in terms of cosine and vice versa. Functions allow us to write a ratio of sine in terms of cosine and vice versa. The cofunctions. What is the sine of 90 degrees minus theta? The sine of 90 degrees minus theta is the same as in which quadrant is that one, right? So 90 minus is actually in the first, because if you have these 90 degrees and then you have 90 degrees minus, so it's in the first where everything is positive, right? So cofunctions, the cofunctions allow us to use something called the Coco rule. Well, now with the notion of the Coco rule, cofunctions allow us to write the ratio or a ratio of sine in terms of cosine and vice versa. Like if you deal with the sine of 90 degrees minus theta, right? So the sine of 90 degrees minus theta, in which quadrant is that one? Right, so it's in the first quadrant and the result is positive, but the sign changes to its cofunction because at 90 degrees, there's no co according to the Coco rule. Now, what you do is you put on a co and it becomes cosine. Okay, because the full name of this is the sine. And then you have the cosine. So there was no co at the beginning of the sign. But suddenly you put the co, it becomes cosine. The cosine of 90 degrees minus theta, in which quadrant 90 degrees minus theta is in the first quadrant, but there is a co, so you remove the co like this, and then you left it sine. But it's 9 minus, so it's positive in the first quadrant, all positive in the first quadrant. But also now you are not really in the first quadrant. So if you say 90 plus, you are in the second quadrant. Okay. 90 plus, you're in the second quadrant, because now if this is 0 degrees, 90 degrees, and then you have 90 degrees plus, you're increasing the angle of 90 degrees towards 180, and then you're roaming in the second quadrant where only this sign is positive. The implication then is that in the second quadrant, the sign is positive, but it changes to a cofunction. There was no co, so you put the co on the sign, then we have the cosine. Okay, so the cosine of theta in full is how you write it. All right, so if you write it this way, like the cosine of theta, but the mathematicians agreed that you leave out, so you write it as just cos theta. In which quadrant is 90 plus? It's in the second quadrant, but the cosine actually is negative, but you remove the co, and then you're left with the sine of it. But it becomes negative. The cosine is negative in the second quadrant. Second quad. Let's look at an example that you need to simplify as they come in the metric finals. Right, so at this point, you're going to have, for instance, this. Right, so you're going to have the following. You need to simplify. So to simplify this, how do you simplify this? Okay, so you're gonna practice with this. I'm planning that you practice by watching the video, writing down the notes of the examples and the exercises and the solutions we wrote together, and then you close our answers, you look at the question, you write down the question, you close the answer. But first you must study the answer and then close the answer and see if you can be able to get the answer on your own. That is how you learn mathematics. Okay, then I'm going to assess you on these things as well and the past exam questions. If you need to simplify without using a calculator, you'll say 2 the sine of 180 degrees minus x. The cosine of 360 degrees minus x divided by the cosine of 90 degrees minus x. Cosine of 180 degrees plus x. Okay, in each quadrant is 180 minus. We saw that 180 minus is in which quadrant? Is in the second. And in the second quadrant, the sign is what? The sign is positive. So it becomes positive, the sign of x. 360 minus, we saw that this one is actually in the fourth quadrant. And in the fourth quadrant, the cosine is positive. 90 degrees minus is in the first quadrant. In the first quadrant, all the geometric functions are positive. Right, but this one used the Coco rule. You remove the co, and we are going to be left with the sign of x. Okay, we continue like this. Then, in each quadrant is 180 degrees plus x. 180 degrees plus x is exactly in the third quadrant. And the third quadrant, we have that the cosine is negative. So it's negative because the third quadrant has only the tangent positive. The cosine is negative, so it's negative cosine x. Now, at this point, you're able to see that the sine cancels, the cosine cancels, and then you're left with 2 in the numerator and minus 1 in the denominator. And the result is minus 2, and we're done. So that is example 1. Okay, so we have simplified these to an integer. Your simplification must always lead to normally a single trigonometric ratio or an integer. Let's look at example 2. Example 2, you need to simplify the following. You need to simplify the tan of 180 degrees minus x, the cosine of that. Let's just look at how to simplify this here. To simplify this, we start by writing the question. The tan of 180 degrees minus x, we're familiarizing ourselves with the question. The cosine of 360 degrees minus x plus the cosine of 90 degrees plus x, all divided by the cosine of 90 degrees minus x into the sine of 90 degrees plus x. In each quadrant is 180 degrees minus. It's in the second quadrant, where in the second quadrant, we have that the tangent is negative, the tan of x. In each quadrant is 360 minus. It's in the fourth quadrant. And the fourth quadrant, the cosine is positive cosine x. Plus, in each quadrant is 90 degrees plus x is in the second quadrant, where the cosine is negative, but it changes to its co-function. There's a co. You need to remove the co, and you're left with the sine, but it's negative. 90 minus is in the first quadrant, where all trigonometric functions are positive. The result is going to be positive, but by the Coco rule, at 90 degrees, you remove the co, and we're left with sine, but everything is positive. 90 degrees plus is in the second quadrant, where the sine is positive, but because of the 90 degrees, you put on a co, and it becomes the cosine of x. What is this? This is minus the sine of x the cosine of x minus the sine of x. And then in the denominator, we have the sine of x, the cosine of x. Okay, we continue and we simplify this. So this one cancels out, and then you are left with the sine minus the sine of x divided by the sine of x, the cosine of x, which is minus 2 the sine of x, the sine of x, the cosine of x. So this divides, and then you have minus 2 divided by cosine x. And now this has just been simplified to a single, trigonometric ratio of x. Just been simplified to a single trig ratio of x. No further simplification is possible. We'll do one more example that requires further simplification. In example 3, we need to be able to simplify that. Let's look at the simplification of this. Right, it's already been done, but we're practicing here ourselves. Let's look at this. So if you look at this particular one, right, writing down exactly the exercise here, with the example, it becomes a sine of minus 180 degrees minus theta into the cosine of minus 180 degrees plus theta, the tan of minus theta, plus 1 plus the cosine squared of theta minus 360 degrees. So this minus 180 minus theta is actually a negative angle, and we have spent time on it and realized that this negative minus 180 degrees minus theta is actually an angle in the second quadrant. Okay, right. So an angle in the second quadrant that way. So in the second quadrant, if we, as it is, the sign is positive there. So therefore, this becomes just the sign of theta. Okay, we just saw the diagram there. So this becomes the sign of theta. Right. So now here, also have another negative angle, the negative 180 degrees, but 180 degrees minus 180 degrees plus, we said it is in the third quadrant. In the third quadrant, the cosine is negative, so it's minus cosine theta. We said negative theta is in the fourth quadrant, and the tan is negative there. Plus 1 plus minus 360 degrees and theta is a negative angle. So being a negative angle, that's something we know that it is in which quadrant this, so it is a negative angle. Right, so this negative angle, theta minus 180, theta minus 360 degrees, in which quadrant is that one, right? So we realize therefore that this one takes us to the first quadrant where all these are positive, so it's going to become just positive cosine with a square. Okay, now what is all this here? Right, so we have negative and negative, which becomes a plus, and then you have the sine cosine, and then you have the sine theta, cosine theta, plus 1 plus cosine squared theta. So as a consequence, what we're getting is this one cancels, no, it is cosine that cancels cosine. So obviously that is obvious. All right, so cosine cancels cosine. You're left with sine times sine, and sine times sine is the geometric sine squared. Okay. plus 1 plus cosine squared. What is sine squared plus cosine squared? Is 1 plus 1, which is 2. Meaning the answer is 2. The result is 2, which is what they got. All right, so we had to simplify, and it has simplified to an integer. Integers themselves are members of Z, like -3, -2, -1, 0, 1, to name but a few. In example 4, we need to just perform another simplification that comes in the matric finals. In the matric finals, a student must be able to simplify this kind of a problem. Let's look at that. So this says we need to evaluate, the word evaluate is saying we need to determine the value of. The word evaluate has value in it. Right, so if you want to find the value of that, so you'd have the cosine of 120 degrees times the tangent of 2 to 5 degrees. I'm going to test you with these kinds of things. So exactly, because these are the questions that come in the matric finals. The examiners use exactly this book to set the final paper. So just be ready up there. Okay, so now to deal with this one, with the numerical angles, where we need to evaluate finding the value of this, you need to reduce all these to acute angles. That is the secret. Acute angles are those angles, acute angles are those angles less than what? 90 degrees are called acute. So if you look at the angle of 120 degrees, you can be able to adjust that one by saying it's 180 minus 60. 180 minus 60 is actually 120. One way of doing that. And then here you can do the tan of 2 to 5 is the tan of 180 degrees plus 45 degrees. Right, here you have the sine of 270 degrees. You divide these by, in each quadrant is this one here. We said the negative 60 or negative theta, our angle is in the fourth, so the sine is negative there. And then we have the cosine of 360 here. You can use your 360 degrees plus 120 degrees is 280 degrees. In each quadrant is 180 degrees minus. Okay, 180 degrees minus. Remember, we spoke about that one. It is in the second quadrant. In the second quadrant, the cosine is negative. So it becomes negative. You have cosine 60 degrees there. Okay, in each quadrant, 180 degrees plus, 180 degrees plus is in the third quadrant, and the third quadrant, the tangent is the only one that is positive. So the result becomes positive, the tangent of 45 degrees. Okay, and then you also have this one. This one, you use a calculator for it, but you realize I'm going to teach you how to do it. But now this kind of an angle is a cardinal angle. It is an angle at the polar angle, and therefore it is the sine of 270 degrees is a -1. We proceed in the denominator, and then we find a couple of things like minus the sine of 60 degrees. In each quadrant is 360 plus. 360 plus is in the right. 360 plus is actually in the first quadrant where everything is definitely so positive. So it becomes positive 120 degrees. Okay, it should have cancelled with the other one, but it's okay. Which if we had left the cosine 120 there, but it's fine. Okay, what I realize is you can write this one like that. So we have minus the cosine of 60 degrees minus the tan of 45 degrees, all divided by minus the sine of 60 degrees. Okay, and then we have the cosine of 180 degrees minus 60 degrees. So what do we get out of these? So in the end, then we multiply negative times negative there, which is positive at the top, which is the cosine of 60 degrees, the tan of 45 degrees, divided by the negative sine 60 degrees. And this quadrant is 180 minus. Is actually 180 minus is in the second quadrant where the cosine itself is negative. Right, so it is negative cosine 60. Right, so you can, that is, if you want, you can cancel out the cosine 60, you can cancel them out, but you can just express them as trigonometric ratios. The things we call special angles. The special angles. What are the special angles? I can draw these and draw these here. Okay, so this is going to be, for example, 60 degrees, 30 degrees. Square root of 3, 2, 1. Always like this. And then there is another special angle of 45 degrees. Okay, so we have 45 degrees. I'm here to test you. I'm going to give you an assessment from this. Square root of 45, this one is always the square root of 2, or 45 is always square root of 2, 1, 1. What is the sine, the cosine of 60? It's adjacent of hypotenuse, which is 1 over 2. The tan of 45 degrees is adjacent of hypotenuse, which is actually 1 over, in fact, it's opposite of adjacent. Okay, so the tan of 45 degrees using SOHCAHTOA is opposite of adjacent, so it is 1 over 1. The sine of 60 degrees here, at 60 degrees, the sine is opposite of hypotenuse. Sine of 60 degrees is minus the square root of 3 over 2. Okay, sorry, if the cosine of 60 degrees, cosine is adjacent of hypotenuse in view of SOHCAHTOA. So SOHCAHTOA means the cosine is going to be adjacent of hypotenuse. So dealing with the angle of 60 degrees, adjacent is 1, hypotenuse is 2. Right, so we are in business and everything is clear, meaning that this half cancels out. In the negative and negative, they give us a plus. Right, so you're only left with 2 over the square root of 3. If they made a mistake, they wrote it as this, but yeah, it must be the other way around, because this one will cancel this, the negative will cancel out, and we have 1 divided by the square root of 3 over 2. It is 1 basically divided by the square root of 3 over 2. 1 multiplied by the square root of 3, which is 2 over the square root of 3. That's the answer. So we had to evaluate, we had to find the value of this, and we found the value. What is the value? The value is 2 over the square root of 3. Some practice example here where we need to be able to determine the following. Right, so determine the value of the following in terms of P. For instance, we need to determine the cosine of these. The cosine of these. What is the cosine of these? All right. The cosine of these. Okay, we're continuing. Okay. Right, we're continuing now. Right. Determine the value of the following in terms of P if cosine of 63 degrees, it's P, and we need to find that. So there's a couple of ways to do this one, but I advise students to always use a diagram to do these kinds of questions. Never go wrong. In which case, then you find at 63 degrees. This is actually Y and that is X. So in the end, then what you're getting is the following. Right, the cosine is the Hello, dear. Are you still there? I just experienced load shedding.